Okay, so today we're going to solve exponential and logarithm equations. We learned how to go back and forth between exponentials and logs. We can take a log and write both sides as exponentials and take exponentials and write both sides as logs, right? That's the skills we're going to use today. So when you have an exponential equation, that means the variable is in the exponent. So the variable is trapped up here in the exponent. What you're going to do is you're going to change both sides to logs. And when you do that, it's going to release that exponent. It's going to separate that exponent from the base and allow you to solve for that variable. Okay? It's the only way. We're going to do the inverse. This is exponential. The inverse is log. Okay? When we solve equations, we do the inverse to solve, to undo things. So to undo this exponent, we have to change it to log. Now, before you can do that, your exponential term has to be by itself. They cannot be anything added or subtracted to that, or multiplied or divided by that exponential term. In other words, 2 to the x has to be alone. Now, I can have other stuff in the exponent. It can have 2 to the x plus whatever, but it just has to be that base to that exponent equals whatever. Okay? And so, for number 1, the only thing we can do is we can change both sides to logs. Remember, if you have an exponential and you have a log, the base is the same, right? So, this is going to be, we're going to change this to log base 2 of 2 to the x equals log base 2 of 7, because what I have to do to one side, I have to do to the other. Now, what happens to the left-hand side? Log base 2 of 2 cancels. That was one of our properties yesterday. Log base 2 of 2 cancels. This is the reason why we do that. Leaving me with just x on the left. It released that exponent. So x equals log base 2 of 7. Now, I know that since you're here, you are able to use this calculator, and you can use the math log base function to change this so we can calculate this. We want to calculate it to the nearest 100. But before you do that, you need to know how to do it if you're at home and you don't have this calculator. Yesterday, we learned the change of base formula, right? The change of base formula changes it to common log so that you can use the log button on any calculator, okay? And so, how do I rewrite this using common logs? What's my numerator? Log what? 7 over log of 2. Log of the number divided by log of the base. Now you can use the regular log button on your calculator, because most calculators don't have the ability to change the base. They just have log and natural log. Log is base 10, natural log is base what? E. Ln is log base E. Okay? So, if you have a calculator that can calculate that, great. Do that. But make sure you change the base to 2. But if you don't have a calculator that can change the base to 2, then do this. You'll get the same answer both ways. So, x is approximately equal to what? 2.81. Okay, for number 2, before I can change anything to logs, I have to have that exponential by itself. So what am I going to do? Subtract 5 from both sides. So I have 10 to the x equals 55. Now you're stuck. The only way to release that exponent is to do the inverse, which means change it to logs on both sides. It's going to be log base what? Right. Log base 10 of 10 to the x equals log base 10 of 55. Now, log base 10, that's your common log. That's your regular log in your calculator, correct? So the right-hand side, there won't be anything to change. But log base 10 of 10 cancels. That leaves me with x equals log of 55. Now, anybody has the ability to do that in their calculator because that's just the common log. So x is approximately equal to 1.74. If there was base e right here, would that change the process at all? No, e is just a number. That's all it is, okay? So let's go look at number. Okay, so somehow we skipped 3. Let's look at number 4. 4e to the 2x power equals 5. We have to solve for x. Is my exponential term by itself? No, what do I have to do? Divide both sides by 4. I don't care what's in this bit. I don't care what the exponent is. I can't have anything multiplied to my exponential term. This is my exponential term. This is what I need to have by itself. Okay? So, I'm going to divide both sides by 4. So we have e to the 2x equals, I'm going to leave it 5/4. Now you can put 1.25, that's fine. But if you divide that and it gives you some decimal that you need to round off, you do not want to round off as you go because your final answer will be not accurate. Okay? So leave it 5/4, or you can put 1.25 because that's rational. Okay, so now I need to release that exponent. So what do? Change both sides to logs, right? What's the base? Log base e. Log base e of e to the 2x equals log base e of 5/4. Now, log base e, that's the same thing as what on your calculator? ln, right? So, first of all, on the left-hand side, that cancels, leaving me with just 2x equals, I'm going to write ln of 5/4. So I can use that ln button in my calculator. Now, before I calculate ln of 5/4, that's probably going to be irrational. I'm not done getting x by itself. What do? Divide by 2. Well, that's okay, because, see, this is just ln of 5/4 is just a mathematical calculation. Okay? We're just going to do it all in one step. So, divide both sides by 2. Now, calculate ln of 5/4. Get that answer, you divide it by 2, round it to the nearest 100. 2 places after the decimal. What y'all get? 0.11. Once you get your exponential term by itself, do yourself an organization favor. Put parentheses around both sides because you're taking the log of this whole thing on the left and the log of that whole thing on the right. Okay? Because I'm seeing some of you, when you're doing the log of the left-hand side, you're leaving off part of it. All right. First step, subtract 8 from both sides, right?
Exactly. Positive. Like exactly.
Okay, so now we have negative 12 e to the negative x equals negative 1. So now we divide both sides by negative 12. And that gives me e to the negative x equals positive 1/12. Okay, so now we're at the point where we would take the log of both sides, right? So I'm going to do myself a little organization favor. Keep those things together. So now I'm going to take the log base e of both sides. Log base e of all of that, e to the negative x, equals log base e of 1/12. Log base e of e cancels, leaving me with just negative x equals, that's ln of 1/12. But I don't want negative x equals, I want x equals. So at that point, I'm going to divide both sides by -1. So that I have positive x equals ln of 1/12 divided by -1, 2.48. So what happens if we have an exponential on both sides? There's a variable in the exponent over here and a variable in the exponent over there. We're still going to do the same thing, but it is not going to be beneficial to you unless the bases are the same. The bases have to be the same because what's happening is those bases cancel, right? When you take the log base 10 of 10 to the something, that base cancels, leaving you with only the exponent. Well, if what's on the other side is not the same base, then it won't cancel on the right-hand side, so it doesn't release your exponent. You understand? And so what you have to do now is make them be the same base. So 100 can be rewritten as what to the what power? 10 to the second power. Okay? Sometimes you have to manipulate both sides to be the same base. Okay? And so, since I can rewrite 100 as 10 to the second power, that is what I need to do first. So this is still 10 to the x minus 3 equals, now that's by itself. So I'm going to do my little organization trick and I'm going to put that in parentheses so that I keep that together. Now, 100 I'm going to rewrite as 10 to the second power. But I don't lose this 4x minus 5. So this is 10 to the second power, and then I still have that 4x minus 5. So what it does is it adjusts that exponent. The exponent is going to change. We're going to distribute that 2 in the top in our exponent so that we simplify that, okay? And so we're going to distribute that 2. So we have 10 to the x minus 3 equals 10 to the 8x minus 10. Now I have exponential equals exponential, and they both have the same base. So now I can take the log base 10 of both sides, and both of those bases will cancel, leaving me with just the exponent equal to the exponent. Do y'all see that? So, eventually, when this happens, you'll stop doing the next step that I write, and you'll just see that the exponent equals the exponent as long as the bases are the same. But I want to show you why first. So log base 10 of 10 to the x minus 3 equals log base 10 of 10 to the 8x minus 10. So log base 10 of 10 cancels on both sides. That cancels and that cancels, which is the reason why we changed that to 10 squared. So that released the exponents on both sides. So we only have x minus 3 equals 8x minus 10. Now that's just a regular equation solved. Okay? So when we solve that, I would subtract x from both sides. So then I have negative 3 equals 7x minus 10. Add 10 to both sides. Seven x equals 7. And x equals 1. So when you have the exponential by itself on the left and the exponential by itself on the right, if the bases are the same, you can skip this step right here and just cancel the bases and set the exponents equal to each other. Everybody understand that? There's a problem in your homework. Now, I'm just going to jot down an example of what the problem would look like, where you would have to manipulate both sides. I'm not going to work through the whole problem because I'm actually just going to make this one up. But it's like 4 to the x minus 5 equals 8 to the 7x or something like that. I can't turn 8 into 4 to the something power, right? Right? But what can I make them both be? Something. I can make them both be 2 to the something power. So you would have to change 4 to 2 squared, and you would have to change 8 to 2 to the third. Okay? So that's how you would do that problem. So this would look like, so keep that together. So this would look like 2 squared times x minus 5 equals 2 to the third power times 7x. Okay? And from there, if you would take the log base 2 of both sides, both of those 2's cancel. So that leaves you with this equals this. And you would solve for x. Okay? Now, when we're solving for x in an exponential problem, x can be anything. X can be anything. No matter what I plug in right here, it's okay if I have a negative exponent, or if I have a positive exponent, or if I have a fractional exponent, it doesn't matter, right? Right?
Right.
And that's because the domain, when we graph an exponential, the domain is all real numbers. That means x can be anything, right? But when we graph logs, there were restrictions on x. There were things that x couldn't be, right? Because we had that vertical asymptote. So there were places that x could not go, right? And that's the reason why is because when right now we're going to solve logarithmic equations, but when we get our values for x, and I'll show you how to do it in a minute, but when we get our value, we have to go back and make sure that it's something that x is allowed to be. You cannot take the log of a negative number. So this is log of 3x. If x ends up being, say, -1, then that's no solution, because when I plug it back in, that'll be this log of 3 times -1, which is -3. So when you plug that x back in, if it makes it to where you have the log of a negative number, it's no solution. That solution is not a real solution. It doesn't count. If you're solving for exponentials, it doesn't matter. But when you're solving in logs, it matters. You cannot take the log of a negative number. It cannot equal the log of a negative number. Okay, so in these problems, you want to get the log by itself. So we want to have log base 10 of 3x by itself. We don't want anything added to that log, subtracted, multiplied, or divided. We've got to get rid of those things first. So we have to get this alone. Well, 2 has multiplied it, so that means I have to divide both sides by 2. Divide by 2, and that gets rid of that. So now I'm left with log base 10 of 3x equals 2. Okay? The variable that I'm solving for is trapped inside that log. It's trapped in here. The only way to release it is to change it to exponential form. Remember that logs and exponentials have the same base. Okay? So this is my little organization. You can keep that together and keep that together. What's my base for that log? 10. So I'm going to say 10 to the log base 10 of 3x equals 10 to the second power. Now, 10 to the log base 10 cancels, leaving me with just 3x equals 10 to the second power, which is 100. Now it's just a regular equation. Divide both sides by 3. And x equals approximately 33.33. So you're taking your base and you're raising it to everything on the left, and you're taking that same base and you're raising it to everything on the right. Your problems are not going to put the log in parentheses, so it may help you to know it's log base 2 of all of that. Okay? So that may want to be your first step. Now, for number 1, I got 33.33. If I plug it back in, 3 times 33 is a positive number. So it's good. It's a good solution. Okay? All right. So for number 2, we're trying to get log base 2 of 16x to the 5th by itself, right? And so I need to get rid of this 1/2. How do I do that? Multiply by 2. When I multiply by 2, it gets rid of the 1/2. So I have log base 2 of 16x to the 5th equals 16. Okay, I've got my log by itself. So I'm going to remember to keep that together and that together. What's my base? So it's going to be 2 to the left-hand side power equals 2 to the right-hand side power. So, yeah. So 2 to the log base 2 of 16x to the 5th equals 2 to the 16th power. This was everything on the left, and this was everything on the right. Now, 2 to the log base 2, what happens to that? Cancels. So I'm left with 16x to the 5th equals 2 to the 16th power is 65536. Oops. What's the next step? Divide by 16. And I get x to the 5th equals 4096. What's the next step? Take the what root? The 5th root. Take the 5th root of both sides. Since I'm taking an odd root, do I need to do plus or minus? No. Odd roots, you do not do plus or minus. So x equals 5.28. What if this problem had ln of 16x to the 5th? What's the base? E. So the only difference is you would have e to the left-hand side power equals e to the right-hand side power. ln is a log, natural log base e. Okay? As in number 3. So here's my problem. That's what I'm taking the log of. As long as x is not a negative number, then it's a good solution. What's step 1? Subtract 5. You got to get rid of this. So 2 times ln of x equals -1. Then what? Divide by 2. So ln of x equals -1/2. But I have my log by itself, right? So you guys just told me what's the base for that log? That's base E. So my base for my exponential is going to be E. So remember, keep all that together, keep all this together, and I'm going to do e to the ln of x equals e to the negative 1/2. Now, since this was base e, e ln, e log base e cancels. Okay, you can change that to log base e if you want. Okay. Let me just show you so no one gets confused. This is the same thing as e to the log base e of x. ln of x is log base e. So that cancels, leaving me with just x equals e to the negative 1/2. And calculate that.
So E's a number, right?
E is a number.
Right, you don't know a number.
It's 2 point something. But on your calculator, it's right above, top, underneath 5. Okay, so you should have gotten 0.61. Okay, for number 4, there's a problem. I have 2 logs. I only want 1 log. So what do? What can I do? No, if you add ln to both sides, then the other side will be 1 plus ln 2. That doesn't help me either. I heard somebody say it. No, you don't divide. What do we do for homework last night? Condense it. We can condense them into 1 log. So, how do I write this as 1 log? That'd be ln of what? X minus 4. What? Huh? Thank you. Divided by 2.
Oh, because it's subtraction.
Because it's subtraction.
Oh,
Okay, there's a reason why you learned how to do what you did last night. Okay? Now, ln is the same thing as log base e. Okay? So, I'm just going to rewrite it just so no one gets confused. Okay? So, I've got my log by itself. So, what's the base? E. So, it's going to be e to the log base e of x minus 4 over 2 equals e to the 1 power. All right, so that cancels. And this is just x minus 4 over 2 equals anything to the first power is just itself. Not yet. Is that it? Do we know what x is yet? No. We don't know what x is yet. What's the next step? Multiply by 2. When you multiply by 2, that cancels. So we have x minus 4 equals 2e. Don't put e2, put 2e. Now what? Add 4. I'm not going to calculate e until I get to the very end because it's an irrational number. So you would have to round off. So x equals 2e plus 4. Now calculate 2 times e plus 4. When we did the exponentials and we looked at the problem for exponential on both sides, those bases ended up canceling, right? As long as the bases were the same. Well, the next problems will have logs on both sides. As long as the bases are the same, which they will be, you can't manipulate a log to change the base, okay? So, the problems you will be given You will have logs on the left and on the right, but the bases will be the same. So as long as you have a single log equal to a single log, when you raise them up, those logs will end up canceling. Okay? Now, but you have to have a single log equal to a single log. So if you have more than one log on one side of the equation, you have to condense that before you can do anything else. And that's what the next problem looks like. Number 5. Okay, so here are what we're taking the logs of. Okay? You can only have a single log on the left and a single log on the right. We have a single log on the left, so we're good. Correct? There's only one log on the left. But on the right-hand side, I need to condense that. So this is log base 3 of 4 what? What does this do? That's my exponent, right? So this is 4 to the third power. You have to put this exponent back. Okay? So that's log base 3 of 4 to the third power. Now I'm going to write every step. Okay, so that equals log base 3 of, let me condense this. So that's 4 to the third power, and then what? What do I do with the 2?
Divided.
Do I do times 2 or divided by 2? Divided by 2, because of the subtraction sign. So that's 4 to the third power divided by 2. Now we're going to simplify that. 4 to the third power divided by 2. You guys tell me what that is. Very good. That's 32. Okay, so I have log base 3 of x equals log base 3 of 32. My base is 3. So I will say 3 to the log base 3 of x equals 3 to the log base 3 of 32. And what happens on both sides? They cancel. 3 log base 3 cancels. Here and here. So that just leaves me with x equals 32. Now, you have to go back and look in your problem and say, is it okay for x to be 32? Yes, that's a positive number. I'm fine. I want y'all to do number 6. Okay, so you should get y equals 16. So we have $500, that's our principal. It pays 6.75% interest, so the rate is 0.0675. How long will it take for solving for t? How long will it take it to double? So the money we end up with is $1,000. Before you can solve that, you have to have e to the 0.0675t by itself. What's the first step? Divide both sides by 500. So 2 equals e to the 0.0675t. What do I do now? How do I get that variable out of the next one?
Huh?
That's bad.
How do I get the variable out of the x? I'm solving for t. Log. Take log of both sides. Take the log base e of both sides. Log base e This is like the first set of problems we did. When we had exponential form, we had to change in the log. So this cancels, leaving it, what log base E is the same thing as ln. So ln of 2 equals 0.0675 t. Now what? Divided by 0.0675.
It's 2017.
Okay, this is your homework.
Boy, you know.